With this video, I'd like to introduce the folder structure and preliminaries for the ASE lecture this year. First of all, I assume that you are already logged into one of our pool room PCs via the No Machine client. And then you will actually see in the background here our nice university in front of the Teutoburger forest. So now we have here our home folder, which we can open with a double click. And this is located under /homes/ whatever your username is. Mine is t-korthals. So we will also work with another folder, which is located on a local disk called m_localdisk. Here you will find a folder userdata, and here we already see a folder of another student, and we will add our own user folder here into this directory. So I will create a folder by right-clicking, choosing Create Folder, and then type my username, which is t-korthals. Create. And if you don't want other students sneaking into your project files, then I recommend that you change your properties for this folder and then just go to the tab Permissions. Then you have owner rights, group rights, and other rights. And here you can choose for groups that they have no access. Yes, we want to apply that. And also others shouldn't have any access to this folder. Okay, since we now want to work with ROS, we have to create our Catkin workspace folder into our user folder. We open it and then create another new folder called Catkin_vs, which stands for workspace. The next step will be to download the Eclipse programming environment, which will help you with your programming task. So first of all, we start our web browser. Then we type into any search engine you like, Eclipse CDT. And you will probably find something like Eclipse CDT, the Eclipse Foundation, or something similar. So the Eclipse CDT is the C/C++ development tooling, which is important that it is particular this Eclipse CDT. There are many different others and also the generic Eclipse environment. But since we only work with C and C++ projects here in our ASE lecture, we particularly need the Eclipse CDT. So now you can click on Download. And then you will find a long list of prior versions, but we choose the most current one, which is the CDT 9.11.0 from 2020-03. And just click on the link here. So here we come to the download page, and since we have a Linux environment, we will download the Linux 64-bit version. Just click onto the download button and the download will start. Just download it into your downloads folder, which should be done in a few seconds. Okay. We can now close the browser. We will now change to our home folder under /home/ whatever your username is and go to the downloads folder. So here we will find our packed version of the Eclipse CDT environment, and we can directly extract it to our local disk, which is called m_localdisk. We just search on other locations for m_localdisk, go to userdata, go to the former created user folder, and then just click on extract. Okay, this is it. An optional note is here that you shouldn't extract the Eclipse CDT or any other workspace into your home folder, which is located under homes, whatever your username is, because this is a net drive. And especially for compilation and other stuff, this folder is extremely slow. So now we go to m_localdisk, user data, whatever your username is. And now we will find the Eclipse folder here. We can go into this folder and just run Eclipse. Okay, now we also have to choose the Eclipse workspace. And of course, we will also choose again the folder on m_localdisk. Again, go to other locations, m_localdisk, user data, whatever your username is, and just choose this folder here. We will definitely use this folder for our other projects, and then launch Eclipse. Okay, this is it. You will be greeted with a huge welcome message. You can just click it away. And this is your programming environment. It is important to highlight that this is not the intended way to run your Eclipse CDT programming environment. So we will close it. Yes, we want to exit. The reason is that if you run Eclipse here from your folder structure, then some of the environment variables which are necessary for compiling ROS projects are not present. These environment variables will be set from your terminal, and therefore we will now introduce the terminal from which we can securely run Eclipse. So we can now close the file manager and open the XFCE terminal emulator, which will be definitely your friend over the next few months. So we are here located in our home again. We can check that by typing in pwd. So we are here in /home/ whatever your username is. And we can also browse this folder structure by just typing ls. And here we see some familiar folders like downloads. However, we want to edit a terminal-specific file called bashrc, which introduces environment variables to your system, especially to your terminal. So we type in gedit .bashrc. So you'll see kind of clumsy configuration file, which defines the behavior and all the environment variables for your terminal. Just scroll to the end. It is important that you introduce all the changes you want to make in the end of this file, because this is always executed or defined in the last stage of interpreting this bashrc file. However, we see here the section ASE configuration. I provide you this text here into the via the Lernraum forum, so you don't have to type all the commands here from the screen into your terminal. I just included this here prior to making this video. So we just want to define some ROS specific stuff and also some pool room specific variables, which I will go through now. So in the first line, we will set up the environment variables for ROS. This is the global setup, which introduces the location of ROS commands and ROS packages which are already installed on the system to your terminal. The next line is our workspace specific folder, which is again located under m-media local disk, which is the location of m_localdisk. And then the user data, then this thingy here with the $, and who am I, is just a command which will resolve into your username. So this is a pretty generic command. And then we'll point here to the catkin workspace folder, and then some other folder which is called devil and setup bash, which will be created just in a few minutes. The next thing is very specific for the pool room PCs. We will find here the Gazebo master URI. Gazebo is the robot simulator, and it uses socket communication. So your local IP and also the TCP ports. And since you most probably work with another student on the same PC, you have to redefine ports. Otherwise, you have crosstalk. So the standard port for Gazebo is the 11345. And I will definitely assign a specific port to you during the first exercise. But for now, we leave it like this. If you copy these lines into your bashrc, you definitely have to edit these numbers, so this 11345, when you are working with a pool room PC, of course. When you work with your own PC, then you don't have to do that. However, Gazebo was the simulator. ROS is the actual application, and this also uses socket communication. And the ROS core, or the manager of the whole thing, also runs on a prior specific port, which is 11311. And here again, I definitely will assign a user-specific port to you during the first exercise. The next few lines are some special commands which we introduced to the terminal to make our life easier. So this is optional, but again, it will make your life easier. The first command is the Eclipse command. The thing is that there is already Eclipse version installed on these local machines, but we don't want to use this particular version. We want to use our own version, which we downloaded just a few minutes ago. And again, This is located under media local disk user data. Then this who am I thingy, the Eclipse folder, and the Eclipse binary. And whenever you now type Eclipse into your terminal, then you run your downloaded Eclipse version. Next command which will be introduced is the command create_project. And here you see a very, very lengthy command which is pretty important to generate Eclipse specific project files under ROS. So we can just go through this command right now. So cat-can-make is a ROS specific command which will first of all create a workspace and then build all the binaries. And we have to give this command some hints that we want to work with Eclipse. So the first thing is this -g Eclipse CDT4 Unix makefiles, so that Catkin knows that it has to produce Eclipse specific files. The next command is kind of optional. This will tell the cat-can-make command that we want to create a debug project. So in the case you want to debug your binaries and want to find some runtime errors or so, then it is important to define debug here. If you don't define anything, then I guess it will be a release build, so no debug flags will be included into your binaries. The next command is again important. This will tell Catkin which version of C++ are you using. Since we use ROS Kinetic here, we have to use C++11. So we just give it here as a hint that all the Eclipse specific project files knows the version of our C++ standard. And this is it. So we can now save our file by typing Ctrl+S. We can now close it. And it is now important that you also close the terminal and rerun it again. So now we are greeted with an error. The thing is that now the lines are executed, which we have introduced to the bashrc, and it will tell us something like this here, that the file media local disk user data, whatever your username is, catkin_ws double setup bash, is no file or directory. And of course we haven't created this file yet, and this warning or this error will disappear as soon as we have created these files with our commands for Catkin. So from here on we can change our directory to our project folder, so which is media local disk user data, whatever your username is, and then catkin_ws ws. And for now this folder is empty, and we will create a new folder with the command mkdir, which is called src for source. We will change into this folder, and now we'd like to check out the ASE exercises into this folder. And to do so, we open our browser and we go to the autonomous mini robot project web page on GitHub, and here you find plenty of repositories. The most important repository for you during the exercise is this ASE exercises. There is also another important one which is called Intro to ROS, which will definitely guide you in the first few days and weeks through ROS and will explain a lot to you. However, we now enter this project here, ASE_exercises, and we also have here a minimal quick setup guide. So it will tell us that we have to clone the repository here into our newly created folder, which is located somewhere under catkin_ws/src. And then just copy this command here. We just have to hold the Control and Shift button and then V to include the former copied text here into the terminal, and then hit enter. You'll see that Git is cloning into the repository and checks it out. We can check it by typing ls, and we see the new folder ASE_exercises. We can also enter it, type ls again, and we see now here the Amiro robot folder and exercise folder. And if we compare it here, yeah, this Amiro folder and exercise folder and README folder. You don't see the dotted files here because they are invisible, but you can see them if you just type ls-la. Okay, however, we see that this Amiro robot folder is actually located in another repository. And to check this repository out into your ASE exercises, you have to initialize this folder, which is actually a submodule. However, you do this by, of course, entering your newly cloned folder and then type git submodule update init recursive. We just have to copy this here because we already entered our folder. Again, enter this text here, and it will recursively clone these folders. Okay. Now we can check out the building of the project by just go into the catkin_ws folder. So you should just see the src folder. We can definitely close the browser for now. And now we want to initialize our project and want to build the Eclipse specific project files. For this, we just have to type in create project. This was our newly defined command. We can check it by just typing alias create_project, which is nothing but this command here. So whenever I type just create project, this command here will be executed. So we just type create project, and we now see a lot going on. So ROS builds the folder structure, it builds dependency, it builds message definitions, it crawls through all the folders, links, binaries, and so on and so on. Okay, this is it. We now see two new folders, which is called build and devel, which is, of course, the build folder with all the binaries and the development folder for ROS. So now we can run Eclipse by just typing Eclipse into the terminal. You should now see the Eclipse CDT here. And now we want to import the ROS project. We just type on import project. We look into the general structure here. And then we want to import an existing project into our workspace. So this is everything empty. We have to define the location of our newly defined project. Yeah, luckily we are directly here located on media, localdisk, userdata, which is m_localdisk, and then whatever your username is. We go into the catkin_ws and go into the into the build folder and hit OK. And then we see that Eclipse found a project definition file, and we just have to press finish. So it has imported here the project minus debug at build. And the first thing which Eclipse tries to do is to resolve all dependencies and include files in the project. So here on the bottom right, you see the indexer running. You definitely have to wait until it hit 100% so that all highlighting and syntax errors are gone. However, we can already unfold here our project structure, and the important structure here is actually the source directory. You can unfold it even further, go into ASE exercises, and then you see the former project structure from Git, which we've cloned. You can unfold exercises. Here you see a source folder. And then you see, for instance, here the exercise template for wall following. You can just open it. And we can just scroll through this file and see the big gap here. And in this case, you just have to solve this project by just introducing whatever you think your solution is into this empty block here. So we can just open another tab here by choosing Open Tab. And we are again located here in media, local disk, user data, whatever your username is, catkin_ws. Let's make it bigger here. We can also check it with ls. Yeah, we are here located with build, devel, and src. And also the warning disappeared since we now have created our project files and so on. So the terminal was able to launch the files and execute them. So now we want to see some robots, right? And we can just use a prior defined template here and type in ROS launch. ROS launch is a command which kind of launches manifest files for your projects. and we want to launch a file which is located in our project Miro Gazebo. I just use tab here for bash completion of the commands and project files. And we can also use tab here again to see what launch files are available. And we see here a file called Miro Simple World Launch. And we just use this here and hit enter. And now we should see the gazebo popping up. We see here this little tiny robot, which is, which has a huge blue laser scanner around it, which are the laser scanner rays coming from the laser scanner on top of the robot. Sorry, it's a bit slow here. And here we can also see our little tiny Miro robot with a laser scanner on top. So Gazebo is a simulator. There is also another tool called ROS, which visualizes the data, which gives us introspection into the robot, into the coordinate systems, and so on. For instance, here we now just see our tiny robot. Again, the Miro robot with the laser scanner on top. And here I now go back to the simulator and just introduce an object, for instance. So I just choose here this box and include it here. And now you also see that the blue rays from the laser scanner hits the surface of the object. And we can go back to ROS again and see the hits of the laser scanner with respect to the former introduced object here. Finally, we want to close the loop, right? So we want to use sensor data to make the robot act accordingly. So let me just go back to the terminal. And here, this is the tab or the window which we use to launch the project. And to kill the project or to terminate it, you just have to type Control-C. And you will see some exit messages. This could take some time for shutting down all the applications, servers, cores, and so on. Okay, now everything is done. You always have to wait until the done message. And let me now just show you the one solution to the wall following project. For this, I just let me go to my home folder, and I here have already some prior solution to the exercise, which will just kind of insert the missing text here into this section. So I will close this for now so that you don't see the solution. And I also have a definition file of my world, which you will see later in the simulator. Let me just copy these files into userdata, whatever your username is, catkin workspace, src ase_exercise exercises. Here we have a worlds folder. So I just copy these two files here into the exercise folder. So the world folder goes into the worlds. The wall.world file goes into the worlds folder. Sorry. And we put the wall_following CPP into the src folder. Here is already the template located, so we just replace it here. It will ask for replacing, yes. We go back to our Eclipse CDT. Eclipse will notice all changes you will make to the project as soon as you hit the hammer button. Okay, whenever you introduce new folders, new project files, new repositories, whatever it is, Eclipse will notice it as soon as you hit the hammer. So we see Eclipse build the project again. We can now go back to the terminal. We are here. So now we just want to execute the wall following exercise by typing in ROS launch. Every exercise is located in the exercise project folder, so exercise, and then we type in tab and see the wall following.launch template, again using tab, and execute it. And we now see here Avis and our little Amiro robot, the hits of array with respect to some object, and the program code now tries to let the Amiro run around this object here. We just have seen the Avis visualization. I haven't introduce the gazebo visualization explicitly here. If you want to show the gazebo visualization, you just have to open another tab and type gz client, and the gazebo visualization pops up. And here we see now here this funny object. Which will be, some kind of driven by the Amiro robot and some other objects which are just optional, which are just included for fun here. However, we can now close the gazebo visualization, also close all applications by again hitting Ctrl+C. And this is it. From here, you can try to solve every other exercise on your own.